Okay, so this is 3.1 rational numbers. And, well, we talked a little bit in the first chapter, you know that box that we went through with rational and irrational numbers? Does anybody remember what rational numbers are? Or you could even just tell me what they are not. Like you could tell me irrational numbers instead. Does that make sense? What are rational numbers? Yeah. Good. That's exactly it. Did everybody get that? Okay. So, can be written as a decimal or a fraction. And the decimal can be terminating or it is repeating. So let's start with an example here. Let's say I give you a bunch of numbers here, and I want you to place them on a number line. So we have -2, and I think for this part, maybe you don't really need me. I want you to see if you can do this on your own, and then we're going to go through it together anyhow. But I just want you to get a sense of how to compare these numbers that are all slightly different. Like they're given to you in a slightly different form. So if we have a number line here, let's say we have a number line and we want to basically place these on there. I'm going to give you a minute. Can you please make your own number line and place those and where they would be in comparison to each other? Well, I thought it would make sense to put a 0 in the middle. And that isn't always how we're going to do this, because if we have a bunch of numbers that are way over into the positives, then maybe we don't want to start there and list off negatives. But in this scenario, this kind of makes sense. So to the left of 0, I'd put -1, -2, -3, and on. That's probably enough for these values that we're working with. And then on the other side, 1, 2, 3, and I'll go to 4. Oh, that just seems wrong. Maybe I should balance it out. It doesn't matter, but I like it better that way. So, are we all familiar and comfortable with the number line and the positives and the negatives? We feel pretty good about that. So then the other thing is, if we have all these different numbers, like some of them positive, some negative, some fractions, some decimals, it's probably helpful for us to put them all in similar terms. So convert them so that they're all either fractions or all decimals. It doesn't matter, but it's just a little bit easier if we can make a comparison when they're all in the same form. So it doesn't have to be completely accurate or precise, but can we change -1/3? Do you have a rough idea of approximately what that is as a decimal? Anybody? You can, sure. -0.3, and what happens with 1/3? Do you know what happens if we were to punch it into a calculator or to do 3. So does everybody know this symbol? We put the little line on top. That indicates that the 3 is repeating. So that's an example of a rational number because it's a repeating decimal. And then how about 3.5? We can also rewrite. 3.5, you all know, would be 3.5, right? So now if we want to take these and place them on the number line, let me color code it. So I use the colors as an organizational thing. If you have a hard time with math or just like to keep things organized, I feel like half of the battle is organization. It might be a helpful thing to have different colors or pencil crayons or something, because I don't just do it to make it colorful. It's basically to keep things clear and organized, and hopefully it makes it easier for you to learn and understand. So our -2, I'm going to place it there with the pink. The 3 we know just by looking at it. And then for the negative, I'm going to use the green for that. But the -0.3, what's a good place for me to put it? And yeah. Okay, good. So do you guys see here between 0 and -1? We could sort of look at this as splitting it into 3 chunks, and you see that's a really nice way to do it. So if it's -0.3, which of those lines am I going to be at? The first one, right? So that's where my -0.3 is going to be, which is this thing here. So far, so good? +0.3. Well, do you see it's kind of the same idea? So we could, on the other side here, sort of split it into, I don't know if I did a good job of that, but +0.3 would be around there. And then if we're looking at this last one, which maybe I should have done in the right color, 3.5 would be, wait, did I already do blue? Oh no, this is the hardest part, you guys, keeping the colors straight. Watch this, I can pull up a different color. Let's do green. So 3.5, we would place approximately there. Good? What color was that? Green? Sorry everybody, but I have to say it has to be the right shade. I just like the bright colors. Isn't that so much nicer? Okay, so are we all good with that? And this is kind of like old news. Didn't even need to go through it. Oh boy, I feel like the whole lesson's gonna be like that. Okay, let's just, maybe it's gonna be less than 10 minutes then. Use this symbol or this symbol to make the statement true. Well, if you, for the first example, we'll start off nice and slow. I know you all know this, but are you good with your greater than, less than symbols? Feeling pretty good with those? Yeah, so which way is the alligator mouth going to be open? Did you learn that in elementary school? So, if 7 is bigger than 5, do you see that it would open up this way? We're all good with that? Okay, so this is just recapping or getting us familiar with some of this stuff, but maybe the next one's a little more interesting. If we have 2/3 and we have 3/4, so you have 2 fractions, so it's not quite as straightforward. What's a really good strategy? You might just know this by looking at it, but let's say you have to show your work or prove what you're saying. What's a good strategy to be able to compare these two? Yeah. Find a common denominator. Everybody good with that? So in this case, if I have a 3 and a 4 at the bottom, what's a smart number for me to pick for my common denominator? How about someone who hasn't answered yet? Yeah, 12. Everybody good with that? And we'd get to that by multiplying this by 4/4, multiplying this by 3/3. So what do we actually get here? This is actually 8/12, and this one's actually 9/12. So which way does the mouth open? And when we go to do this, we should use the original numbers and not the ones with the common denominator. We only did that to be able to do the work to make the comparison. But which one would you say is bigger? The 3/4, right? Everybody good with that? So the common denominator is simply a tool that we use along the way to be able to make a comparison. So the thing that I want you to get from this is that when you have something that is different, math is all about looking for similarities. This is like life lessons. Do you know that your life will also go smoother if you look for similarities with the people around you? That's true of math as well. So when you don't have something in common terms, change it and adapt your perspective and look at it differently so that you can get it in common terms. So if here we have -4 and a third, and we're comparing that to -4.5, well, keeping in line with some of the stuff we've kind of been doing, which one do you think would be the smarter one to change the form for? Like right now we have a decimal and we're comparing it to like a mixed fraction or a mixed number. So which one is easier for us to change? Change the fraction to a decimal or change the decimal to a fraction? Well, how about this? There's no right or wrong with that. It's personal preference. But I think for most people, you might find it easier to change this one because we already talked about this. What is a third? This is like saying -4 point, what's a third? We already mentioned it. It was that 0.3 repeating, right? So in this case, which one is bigger? Because we're dealing with negatives. Yeah. -4 and a third is bigger because, do you see -4.5 would be going further into the negatives on the number line? So make sure that you're paying attention to that when we're dealing with negatives in that case. So far, so good? Okay. I feel like you guys are ready for, this next one's a little bit intense, but you seem bored. Can you handle intense right now? I think we need to up this a little bit. Okay, so let's do this. We want to convert the repeating decimal to a fraction. It's hard to write on here. My writing's not normally quite this messy. I apologize. So if we had 0.3 repeating, and we want to convert this into a fraction, I'm going to teach you a strategy that I think maybe is going to be new for you. I would be surprised if you've done this before, but maybe some of you have. Okay, so I'm going to go through a strategy. And let me say this, you don't have to do this. So if you're struggling with this or having a hard time, no big deal. This is not essential. This is extra stuff that I'm going through because I get the sense that you're pretty okay with 3.1. So here's step number 1. Well, first of all, we're going to say that this is like saying 0.333 ... We know that that's indicating that it's repeating, right? We already talked about that. Step number 1 is we would let x equal 0.3 repeating. I'm going to show you. Don't worry, I know this isn't making much sense right now. Step number 2, we're going to multiply by 10 to get a whole number. So let me show you what I mean by that. So we are going to say, instead of this part here, you know how it says x equals 0.3 repeating? I'm going to make it 10, and then the hardest part for me is keeping the color straight. 10x equals 3.3 repeating. So do you get what I just did? I basically took this, oh, that's the wrong color. Okay, I basically took this part and I multiplied both of the sides by 10. I'm allowed to do that because an equation is like a scale. We're allowed to do whatever we want to one side as long as we also do it to the other side. Does that make sense? So if I wanted to multiply it by 1,000,000 on both sides, we can do that. If I wanted to add 5 on both sides, I can do that as long as I do it to both sides. So because of that rule, I've changed this and made it, I multiplied this by 10 and I multiplied that by 10, and it ends up giving me this little equation down here. So far we're okay? Or any questions about that? Okay, so then now that we have that, we can also take this and rewrite it to say, and I hope you're okay with me changing back to just using the green to make it easier, 10x equals, do you see that I can take 3.3 and split it up to say that it's 3 plus 0.3 repeating? So basically, to make this clear, this part is exactly the same as this part. It's just like, imagine you had the number 7 and instead I just wrote it by saying 3 plus 4. Do you see that those are exactly the same thing? So I'm just rearranging it on purpose because of what I'm eventually wanting to do with this. Are we good with this so far? Okay, so now here's the part. This is the only thing with writing on black. I like using the highlighter, but I guess I can't. Will that work? Oh, no, that didn't work at all. I'm trying to see if no, so I can't highlight on here. That's okay, I'll figure out another way. So going back to step number 1, do you all see that x is equal to 0.3 repeating? So if those two things are equal to each other, then I should be able to take this and just plug in an x for it. Everybody see what just happened? And if you feel like, whoa, what is she doing? Don't worry, I mean it when I say this is like bonus or extra. This is not the expectation for today's lesson. This is just because I felt like we were really good with the initial stuff. That's the stuff that's the main focus. This is just like bonus work, so don't worry and let it stress you out. 10x equals 3 plus, and if we just said that 0.3 repeating is the same thing as x, I can substitute in an x. I'm kind of teaching you chapters 5, 6, and on, but that's okay. This is like an introduction to it. And lots of stuff's going to happen in between, so you'll be good to go by that time. So then, if I want to get x by itself, and I have a 10x over here and an x over here, anybody know what I should do next? Yeah. Subtract x on both sides. Everybody good with that? So minus x here and minus x here. An equation is like a scale. Whatever we do to one side, we do to the other. So then let's keep track of what's going on here. On the left side, what's 10x minus x? Yeah, 9x. Everybody okay with that? It's like we're counting up how many x's we have. And on the right-hand side, what's 3 plus x minus x? Yeah, the reason we did it is because that's nicely going to cancel, so it's just equal to 3. So what's my next move? I want x by itself. Yeah, what should I do? Divide both sides by 9 because we want the x by itself, right? So algebra is all about opposites. If they're being multiplied here, then we're going to divide both sides by 9, which is like 9 over 9 just cancels and leaves us with x. Ooh, wrong color. X equals, what's a better way for me to write 3 over 9, or what is it the same thing as? 1 over 3. And if I go back to the question, it said convert the repeating decimal to a fraction. So if you are up for a bonus or the challenge, you can do the questions that are like this. And if you are thinking, no, that was too much, it's over my head, I'm not ready for this, then no big deal at all. You are not expected to be able to do this, but I will have you do numbers 1 to 9 for this. Well, all is a lot. Let's do odd letters. And we'll also do 3.2 in just a bit.